Hello guys, welcome to section 13.1. Now this one is, you notice I don't have a PowerPoint for this, because there's only really one definition that you should get from this, that's on tree diagrams, which I'll just show you. But we're beginning our section that leads into probability, and we're starting with counting methods. And besides of course the obvious is counting it out, in situations, one of the best ways to count out the number of ways of organizing something is through a tree diagram. It illustrates the possibilities that what's eventually going to lead to probability can yield you. For example, if your common way is to list the possibilities of the gender of a child over several generations. Obviously it's boy and girl, so that creates a tree diagram, because each generation you have an equal chance for one or the other. Of course, if when you look at it in a very basic sense. It could also be used often for accommodations for food. Restaurants can use it to figure out the number of possibilities patrons number of ways patrons can order. And as you can see, here's a good example. The first set here we refer to as the first tier. The second one obviously is referred to as the second tier. Let me highlight this a little bit more. Whatever these events are, in this first section we call the first tier, and again, like I said, these are called the second tier. So this one is the combinations of shirts and pants. How many ways can I organize myself to get with 7 shirts, 3 pants, and 3 shoes? So, actually, if I'm mistaken, this should be, this is an older one, it should be, 3 pants and 2 pairs of shoes. So when we list all the possible combinations we have, that's what the tree diagram is for. You could just counter off to yourself. I have my pants 1, pants 2, pants 3, etc. Or we make a tree diagram. So if you go with your pants first, you have 3 choices for pants, hence the 3 initial choices. Within each of those, you can choose 2 shirts from those pants. So to find the total number of combinations you can wear, you count the end of the final tier, which in this case there are 6 markers, so there's 6 possible combinations. Or you can simply multiply. We have 2 shirts, 3 pants to get 6. Like I said, another common use of tree diagrams is to make to look at the combinations a patron has, in this case of appetizers, entrees, and desserts. Now to better illustrate this to you in a quicker way, I'm using the website you can see at the top. Now it may not show up as well on the screen, because it might be a little smaller, so what I'm going to do is I'll copy it and paste it down here for you. And nice and small there. Let's see if we can make that bigger. So there's the address www.stat.stanford.edu/Susan/surprise/probabilitytree.html. That link will take you to the little applet that I'm going to use. Now this is just to show how the tree diagram can be set up. So the first one is there's 8 appetizers. We're going to order. We have 5, 6, 7, 8. So we have 8 appetizers to choose from. So whatever they are, we can of course list them all out. We have 10 entrees. So that means choosing one appetizer, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 appetizers. That's a lot. So far we're at quite a few. And then beyond that, we have 6 desserts. So I'll go up here because you can see it. So 1, 2, 3, 4, 5, 6. Now I don't believe there is a way to draw these out a little more, but the idea is and we just set this one gives you probabilities. When we get to that later on, that'll become a little more useful. So each time, and let me see if I can make this clearer, and I reset it so we get those probabilities out there. You can see, and it's hard to see of course at the very end, but for each of these 8 we have 10 possibilities, and for each of those single possibilities we have 6 more possibilities. Now, obviously it's used to help you out. Now sometimes in this case it's not always practical, but the idea is it gets you to organize the information. And at each stage, as you noticed before, in the previous example, when I do a multiplication of however many choices you have at each tier, you get the total number of possibilities. So in this case, I first have 8, then 10, then 6. That should give me 480 possibilities. So okay, that's how many combinations there are. Okay, continuing on. If I have, how many ways are there to answer a 5-question multiple choice test where each question has 4 options? Well, let me reset this. So 5 questions, so let's say 1, 2, 3, 4, 5. Each question has 4 options, 1, 2, 3, 4. If we count all the boxes along here, we'd have the total number of possibilities, which again would be 5 times 4, or 20 options. So there are 20 ways of answering a 5-question standard multiple choice test. This leads to problems like this, common one with license plates. How many ways can you find a combination? The first 3 spaces are letters of the alphabet, the last 3 are numbers, 0 through 9. Well, it would be the same thing. We just do first time be, if you go in order, it'd be 26, then 26 more, then 26 more. The last 3 would be 10, 10, and 10. So without having to, sketch that, because that'd be very, very detailed, we say, well, there's 26 possibilities the first time. The second letter is still 26, and 10 for each number. And get rid of that. To figure that out, either use a calculator, or if you're really good at mentally, you can do that. So we have ourselves 17,576,000 possibilities, or combinations for this particular license plate. So this concludes the main focus of section 13.1. Again, using tree diagrams to help count possibilities. As always, if you have any questions, feel free to contact me, and have a good day.